Hello everyone. Today we are going to look at integration. Our focus would be on antiderivatives and indefinite integration. The topics we are going to be covering today would be writing an indefinite integral notation for antiderivatives, use basic integration rules to find these antiderivatives, find a general solution of a differential equation, also finding a particular solution of a differential equation. The first thing we're going to do is, what is meant by an antiderivative? So let's start with a very simple example. Now, if I want to find a function whose derivative is 2x, what basically means is, suppose that function is capital F, and the derivative of the function, if I take a capital F, should give me 2x. So if we look back to our knowledge of derivatives, we know that if the capital F of x is x squared, and if I take the differential of this 2x squared is 2x. So the first thing we said was, if we can find a function capital F whose derivative is small f of x, which is 2x. So this function, which is the capital F here, is called the antiderivative of the small f, or this capital F is an integral of f. So that's where the first thing we talk about is antiderivatives. Now the next question which comes up says, is 2x the only derivative of x squared? So once again, the question is 2x the only derivative of x squared? Let's look at some other functions. So let's take capital G of x. This is x squared plus 5. If I take the derivative of g prime of x, let's take the derivative of g prime of x. What do we get? We get 2x. So according to what we just learned, that means g of x is the entire derivative for the function gx. Okay. Now let's look at h of x. My h of x is x squared minus 2. So if I take the derivative of this function, h prime of x, again I get 2x. Similarly, if I have a capital J of x function, which is x squared plus 44, and I take the derivative of this jx, I again get 2x. So what we're looking at is, if you're having a function as simple as f of x, which was x squared, and we already know that the f prime of x was 2x. So we have function capital F, capital G of x, capital H of x, and capital J of x. All these functions have the derivative to be 2x. So what we can conclude is that for any constant c, now remember this 5 is a constant, negative 2, 44, these are all constants. The function capital F of x equals x squared plus c is an antiderivative of f of x. So the c, which is here, is called the constant of integration. So we'll be finding an antiderivative is basically called integrating. Okay, let's look at some notations. Keep in mind, we just said we are looking at a capital F. Okay, notice this one. We says, can we find this capital F whose derivative gives us f of x? So in other words, f prime of x is f of x. And what would you just say? That this capital F, and then we said in our previous slides that this is the antiderivative of f of x, the small f of x. Okay, so How do we write this one down? And not only this f of x, but fx plus capital F of x plus a c, which is a constant, is nothing but represented as the integral sign f of x dx. Now this symbol, guys, is called the integral symbol. And the function, the small f of x, is called the integrand, and c is called the integrand. So the antiderivative of f of x, this is important for us. The antiderivative of f of x is denoted by the integral symbol, then the small f of x dx equals capital F of x plus c. So this was just the very starting of our antiderivatives. Let's go ahead and look at some basic integration rules. Just keep one thing in mind, is that this integrals and differentials are kind of opposites of each other. So when I'm going to go back and forth between these two to show how these formulas of integrals were formed. Now, we all know differential of a constant is 0. So remember, if I take the integrals here, so the integral of 0 dx is nothing but a c. So in other words, if you take the integrals here, the integral and the differentials, they cancel out. So integral of 0 dx is c, where c is a constant. Now we also know, let's look at another scenario where the differential of k times x, we already know is a k. So once again, if I take the differentials here on both sides, when I do that, so this differential, guys, cancels out and we get k dx. Now on this integral formula, so this k dx is nothing but kx, that's the one, plus a constant. Remember, all these integrals, they differ by a constant. Okay, so let's look at this example. So this is what is important for us. This formula is what we'll be looking at. So if I have an integral of a constant dx, automatically, what will be the answer? 7x plus c. Okay, let's look at integral of a pi dx. Now we all know what is pi. Pi is that number 3.14 blah blah blah, you know, all these terms. So integral of pi dx again is going to be pi x plus c. Now we look at some trick. Sine of pi over 2. Remember, pi over 2 is what? 90 degrees. So sine 90 degrees, we all know, is a 1. So the integral of sine pi half dx is nothing but sine 1 dx. And what is 1 dx, guys? So it's a constant. 1 is a constant. So it's simply x plus c. Okay. The most important rule for us is the power rule. What's a power rule? Let's go back to the differential formulas. The differential of x to the power n is nx to the power n minus 1. Oh, that's a typo, guys. We do not need that. Just remove this one. It's a typo. Okay, now remember, you're going to flip here. So if you take the integrals on both the sides, integral of xn dx is 1 over n plus 1 xn plus to the power n plus 1 plus c. Important, n cannot be equal to minus 1. Remember, this is not allowed. And here, once again, this k should not be there. So for us, in integration, this is the most important formula. So any problems we will be doing, guys, we will be looking at, do we have a function inside the integral symbol, which is in powers or like x to power something? And then whatever is the power, the answer to this integral is you add a 1 to whatever is on the power, and the same terms which you get in the numerator, This n plus 1 is what you divide this whole expression by. Okay. Now, and by default, every time add a c, guys. So let's start over here. Some examples. Integral of x dx. Now, what is the power of x? It's a 1. Simple 1. So, looking at this formula, and make sure that n is not equal to minus 1, we write this as what? X. Now, the power is 1. You add 1 plus 1, which is a 2, and that's what you put in the denominator, plus c. So, to write in a much more nicer looking form, this is x squared over 2 plus c. Okay, let's look at the another. Here, x, we're going to find the integral of x to the power 7 dx. Now, our n is a 7. So, according to this integration formula that is the power rule, we write this as what? X to the power 7 plus 1 over 7 plus 1 is an 8. So, the final answer is x to the power 8 over 8 plus c. Okay, let's look to the next one. We're looking at the integral of 1 over x to the power 4 dx. We have to be very careful before applying this formula. The formula has to have x in the numerator. Here the x is in the denominator. We'll apply exponential rules and take this x over 4 to the power 4 in the numerator. So this thing can be written as, so we have to first of all make sure write it in the proper form of what the power rule is asking us to do. X, we take it on the top, and this 4 power now becomes a negative, minus 4 dx. Okay, so n clearly is different than minus 1. We apply this formula. This is equal to x, now minus 4. Remember, you have to add 1 to it. Minus 4 plus 1, which is basically minus 3. So the final answer is x to the power minus 3 over minus 3 plus c. Now, let's look at the last one, the integral of cube root of x dx. Once again, it is not in the form as we are looking at. We have to change this cube root into a scenario where we have an exponential form of it. So the first thing we're going to do is we're going to change the way it looks. So we're going to write this as x to the power 1/3 dx. Now, go ahead and apply this formula, the power rule formula. So it is 1/3 plus 1. Now 1/3 plus 1 is 4/3. 4/3, which we can write as, we can take this 4/3 in the numerator by flipping it. It's 3/4 x to the power 4/3 plus c. Now, let's look at some more rules of integrals. Remember, once again, power rule is a very, very powerful rule, guys. Power rule, very powerful. Okay, now let's go ahead and look at some more rules, as I said earlier. We're going to look at a constant multiple rule. Now let's go back to the differential. If you have a differential of a constant multiplied to a function, we already know, so this is k times, I'm sorry, I forgot to write this one, it is d dx of a function. Okay, so when you look at the integral, so the integral, okay, now this one, integral of k fx dx is k integral fx dx plus c. In other words, it's just basically similar to what you are doing in differentials. If taking a differential of a constant times a function, you basically pull the constant out. And that's exactly what we do in an integral formula. So if you're having an integral of a constant times a function, you basically take the constant out and just do the normal integrals we have just learned so far. Okay, let's do some examples. Let's start with this one. Integral of 5x cubed dx. Now clearly 5 is a constant. According to our rules, we just take the 5 out. See, we take the 5 as a constant and then do x cubed dx, which is now 5. Now this one is the power rule. It will be what? X to the power 3 plus 1 is what? 4. What you have as the power goes in the denominator, 4 plus c. Okay, so we're done here. Let's look at the next problem. We're taking the integral of 1 over 7 x to the power 7 dx. 1 over 7 is a constant, guys. Let's take that out. And now we're going to look at x to the power 7 dx. Now, we can now simply apply our power formulas, which is 1 over 7 x to the power 8 divided by 8 plus c. Much more nicer, we can say x to the power 8. 7 times 8, guys. 56 plus c. Okay. Let me make a little distinction here that this is power and this is in the denominator. So this one, okay, let me just erase this and write it more nicer so that we know that there is, okay. We already have the answer, but just to make it sure. So this one is x to the power 8, kind of little difference I wanted to show here, 56 plus c. Okay, let's look at the last problem. Now you have a negative 2, 1 over x to the power 4. We've already done this one. So let's just go ahead and do it again. So take the minus 2 out, guys. It's a constant. It is 1 over x to the power 4 dx. Now remember, this x to the power 4 should be in the numerator, not in the denominator. So when we take this x to the power 4 in the numerator, the sign changes. So you have negative 2 x to the power minus 4 dx. Now we apply our power rule. We get minus 2 x to the power minus 4 plus 1 minus 3 over minus 3. Now just clean it up. So this negatives cancel. We have 2/3 x to the power minus 3 plus c. Okay, let's look at some more rules. Now the sum and difference rule. Going back to a differential formula, so if you were taking a differential of sum of 2 or subtraction of 2 functions, it was basically like you could do them separately, the differentials of f and g, and then simply add or subtract. That's exactly what you do in an integral formula. So integral of fx plus minus gx dx is the same as you're taking the integral of fx, then plus minus integral of gx dx. Okay, we can actually also generalize it to any finite number of functions. Let's look at this problem. It's the integral of x plus x cubed. So the first one I'll write it down. After that, we can just do it at one go. So this is the same thing as saying x dx plus integral x cubed dx. Now x dx is nothing because the power is 1. We've already done this example before. It is x squared over 2. And we will just write the constant at the very end. We don't want to keep on repeating again and again. Plus x cubed is x to the power 4 over 4, the final answer, plus c. Okay, now this one. Minus 2x cubed plus 1 over 7 x to the power 7. You've seen these things before. Now what you're going to do is, we're going to just apply it at one go. So this will be equal to, now remember it has a constant, so keep the constant next to it and apply the integral over x cubed, which is x to the power 4 over 4. Let me just write it down one more time to show what I'm saying. So it's minus 2 x cubed dx plus 1 over 7 x7 dx. So this is the same thing as saying minus 2 times x to the 4 over 4 plus 1 over 7 x to the power 8 over 8. And remember, the final answer we just write a c. So minus 2 and 4, they can cancel out. We have minus now x to the power 4 by 2 divided by 2 plus x to the power 8 divided by 56. And as usual, the final answer, just put a c. Now let's look at this last problem here. You're given a rational function and you have one term in the denominator. So the best way to what we do is we basically write it in the form of only numerator terms. And we can easily write first this as x to the 5 over x. Remember, we have not yet learned any quotient rule. So we have only learned as a power rule. Plus, in integrals I'm talking about, x dx. That makes life much more simpler. Now, what does this look like? Equals x, now apply our exponential rules. So 5 minus 1, remember, 4 plus x, 6 minus 1, 5 dx. Okay, now this is very simple. We can do it one go. So x4 is what? x5 over 5 plus x6 over 6 plus a constant. Now let's look at a little bit more difficult problems. Here, integral of square root of x plus 1 over 2 square root of x dx. Before we go further, let me just write down the basic formula we're going to be using all the time, guys. X to the power n dx, the power rule, guys. That is the most important formula in our integrals. Okay, this, remember, guys, is a 1. Okay, now let's look at this one. It's a sum of two functions. So what I'm going to do is I'm going to first change this square root into a exponential kind of a function. So I'm going to write this as x to the power half. Now this is a constant, so just write half. Now this square root is in the denominator. Not only we will change the square root into an exponential, but we'll also take it in the numerator, x minus half dx. Now we just go ahead and apply this power rule to each of the terms in this integral. What are we going to get? X half plus 1. Now remember, half plus 1 is what? 3 halves? That's what we write. Plus half x. Now it's minus half plus 1. Now remember, minus half plus 1 gives us a half. And that's what we write. This term we write over here is a half. Now, let's write down much more nicer. Take the terms from here in the numerator. So we flip the term in the denominator. We get 2/3 x. Now remember, half plus 1 is 2/3. Oh, sorry, 3 halves. Yeah, be very careful, guys. This is 3 halves. That remains, but this is what we flipped. Now clearly this half and this half can cancel out. Or we can also see that when you take it on the top, that becomes a half. Okay, so let me just say this is plus half. Now this one which is in the denominator, when it is taken in the numerator, it is flipped 2 over 1. Or you can also see that these can be cancelled, whichever way is comfortable, guys, to you. X. Now remember, minus half plus 1 is simply a half. So what is our answer here? 2/3 x to the power 3 halves. Now this, guys, half times 2 to the power 1, they cancel out, plus x to the power half, the final answer, because you have a very nicer looking answer here, add a c. Okay, let's look at this problem. Integral of 2t squared minus 1 the whole square dt. When you look at this one, we have had so far where there's only one term and we are raising in the expression x as the base and there's something raised. But notice what's over here. The terms, guys, here are more than one term in the base. So what you're going to do is we're going to say, hey, we'll open it up in such a way that we will have these kind of, where we have one expression raised to power something. So going back to our good old college algebra days, this is your a minus b the whole square. So let me write that down. If you just a recollection, guys, a minus b the whole square is a square minus 2ab plus b squared. So that's what we're going to apply over here. So this can be now written as 2t squared is your a. So here my a is 2t squared and my b is a 1. So when you square 2t squared, what do you get? 4. T squared to the square is a 4. Okay, remember a squared is what? 2t squared square. Applying the exponential rules, 2 squared t squared square, which is 4t squared. That's what I've written here. 4t4, sorry. Now, minus 2 times ab. So it is minus 2 times 2t squared, which is basically a, so let's write it down here first. So let's do this math here. So it's minus 2ab. Minus 2 times 2t squared times minus 1. What do you get? A 4t squared. So let's write down the values we got here. 4t squared. And then plus b squared. That means 1 squared. Plus 1 dt. Remember, we just have to be consistent with the variables. Let's go ahead and now just apply it. The integrals, that is basically applying the power rule. And remember, this is a constant multiplied. So you just basically take that out. So this is 4 times t, 4 plus 1. And whatever is here, 4 plus 1 is 5. Plus 4t, 2 plus 1, which is 3 over 3. And it is a constant. Integral of a constant is just nothing but the variable. We are having dt plus t. And nicer looking one, it's 4/5. That's our final answer. T to the 5 plus 4/3 t cubed plus t plus c. Okay, guys. So we have done quite a bit of problems. Now this is what I want you to do before we start looking at other integral functions. So I want you to practice these 6 problems, finding these indefinite integrals. Thank you.